multiplication properties today, so the second chunk of those activities. The what? No, we're going to go over them. We'll do it later. So why do we want to learn about these? Because number one, math is awesome, right? Number two, it helps us to do mental math quickly. Remember when we were doing the distributive property examples yesterday, and you guys did them in your heads already? We did the example with the bowling shoes, remember? And the $4.25, and you guys just did it in your head. You did your 4 times 4, and then your 4 times 25, and we got 17. That was super fun. It was an accident. It was just by natural ability. You already knew what you were doing. So now we're just giving it a name. That's all. So that's called the distributive property. We'll understand how it will make easier, how the numbers work together. And then again, my fun little story that mathematics is just speedy addition. It's funny. It is. Okay, so the commutative property. Remember our code word here is they are commuting, so they're doing what? Switching ways. Make sure we're using our hands, switching ways. So we have our A times B. I wrote 3 different properties. Why? Or 3 different ways. Are they all equivalent? Yeah. Why? What's different? Great. So the signage, right? Because remember, according to PEMDAS, we have P, E, M, D, A, S. How do I write my parentheses? In parentheses, right? How do I write my exponent? X to the number, or N. Multiplication, remember, multiplication can be written multiple ways. My dot, star, X, not Mr. Preferred method.
And parentheses.
Parentheses, 2 sets of parentheses, or if the numbers are just next to each other, right? Yeah, question.
The numbers next to each other should, couldn't it get not numbers?
Okay, sorry, yes, thank you, not numbers. It has to be either 2 variables or 1 number and a variable. And then that's a good question. What is that called when it's a number next to the variable and they're being multiplied? Begins with a C. Coefficient. Remember, like in Spanish, means with. Ven conmigo. Come with me. How do we say that in
¿Cómo
Chinese?
estás?
¿Cómo estás? How are you? Wait, what? Ganwaichi. Okay, so come with me. And then what is our definition of variable again? A letter that takes the place. What kind of a number? I don't know. It's a known. Or I don't know, you tell me. It's a known. I don't even remember my own quotes. That's awesome. Okay, and then division. Multiple ways of writing division. So what do we got?
We got the dots and
The dots?
and
the fraction. And then the garage door.
Oh yeah.
Right? Any more? Can we think of anything else?
The word.
separate.
Yeah. Okay, yeah. So we weren't doing words, and then we have plus and minus. So these are just our signage for our assignment. What?
No, plus minus.
Oh, how can I rewrite subtraction? Good call.
Adding a negative.
Plus a minus, good. And then addition can be written as a double negative, subtracting a negative number. Good job, you guys. Okay, so commutative, switching the order, okay? Then our next one here, some U-tries. So whether you want to use your pad or you want to just do some mental math, let's go ahead and see. Oh, we're going to do them together. Okay, so first one, no, it's okay, go ahead. First one, solution is 27, which would mean y equals 9. Second one,
Solution is.
ooh.
Oh shoot.
11.
132.
132. Good job. And so our S is 11. Then we have K times 4 equals 4 times 7.
So
So
28.
28 is our solution, and K is 7. And then last one, 8 times 4 equals H. 40 and 8. Okay, remember, addition and multiplication are both commutative, meaning you can do them in different orders, but you'll still have the same solution. So that's what we have. 8 times 5 is the same, and so is 5 times 8. And let's see if I did this right. Ooh, it disappeared. I know. It's exciting. I learned how to do some stuff as well. So that's that one. All right. Next, the associative property. Remember we did it with the cardboard boxes because we were associating with different groups of people, and so it's associated with who? And so here we have our parentheses are moving this time. What doesn't change when these two expressions?
The numbers.
The equations, the numbers, the variables, the location
The
doesn't
answer.
change.
Okay.
Alright? The answer doesn't change.
And the equation.
And yes, the equation. Well, yes. It's the same order, parentheses are just moving. Because you're associating with different people. Okay? So with this one, we're moving. What's my solution? And then what's my variable?
Okay, that would be 3 times 8, and then that's 24.
Okay, good. So you did it because these are like terms. We're already in the distributive property again. Combining parentheses first, and then you're multiplying. So that means n is what? N has to be 3. And is that true over here again too?
Yeah.
3 times 4 is 12, and 12 times 2 is 24.
E is
Good.
1.
Next one, E is 1. Very good. So we have 4 times 7 is 28, and then 4 times 7 is
28.
28. Good. Next one,
4 times 7 is 28.
9 times 7 is
Oh, yeah.
3 times 2, 1.
no, 63 plus 18.
It's 9.
Oh,
It's
yeah.
9. It's
Yeah,
9
it's
times
okay.
14.
So it can either be 9 times 14, or like Tiff was doing, he was doing the 9 times 7 plus 9 times 2. Okay? But make sure you're doing 9 times 7 plus 9 times 2 versus 9 times 7 times 2.
123.
123, is that it? I didn't do the solution.
Okay, so.
Have the answers for the variables.
14 times 10 minus.
It's 126.
Good.
126.
I mean 26, my bad.
Good job, you guys. So we have J was 2, and last one?
2 times.
B is 8.
So B is 8. So we have 16 times 5 versus 2 times 40. So 80. Yeah. Alright, cool. Sign language.
I only have one more box.
Alright, next. The identity property. Identity property of multiplication. Any number multiplied by 1 will give you the regular number. So what's 1,500 billion thousand? Which isn't a real
What
number.
is that?
But if it was times 1, it would be
1,500
billion
thousand.
Like in school, like
Like in
what's
school,
6
right.
times a billion?
6 billion. Good. And so this one here, even with negative numbers, it retains the sign. And then even with decimals, it retains the original value. Right? Yay.
Wait.
Question?
What's the identity property for addition?
Ooh, we'll go over that in a sec.
Let's
But remember the identity property of addition. Identity. Remember like the new movie that came out? Identity Fraud? That
I
just
wanna watch
before?
that.
Whether you want to see it or not, yeah, it's kind of sketch. But the whole thing with that is someone's identity got stolen and is used by someone else. So that means the
It's a
new
zero.
or the born identity. Yeah.
Oh.
So somebody else thinks they're somebody else, right? Even though they're not. But anyways, with this one, with multiplication, any number multiplied by 1 gives you itself. So see, its identity is the same. Its identity is the same. Its identity is the same. So with multiplication, the identity property is 1. So that's my multiplicative identity. However, for addition, like Ian brought up, what's the additive identity? Yeah. It's a 0. Because any number plus 0 is itself, or the same. Very good. So that's one of your blanks there, Ian. Nice question, getting that out. Alright, so we all kind of know these ones. Right, times 1. Got it? Good review. Okay, and then 0 product property. Again, 5 million times 0 is 0. All these answers. So this would be 0. This would be. Oh, say it one more time, Thea. Whatever number you want. Because 0 times anything equals 0. Good. I thought it was a bit tricky with that one. Okay? See? Any number. Good job. Good job. And then, I know, I tried. So the distributive property here, multiplication or subtraction. This, whenever we have subtraction on the inside, what did I ask you to do? A plus minus, or adding a negative. All right, we want to change the subtraction that way so we don't forget our negative sign, like who he belongs to. Because everybody wants to belong.
Belongs to me.
Be busy.
I thought we were supposed to do the, like, 9 times 20 minus.
Remember, there's 2 methods. So with this, the distributive property method, you have to find your answer and then figure out what goes there. That one will do it. And what about this one? This would be negative y times what?